Every installer will tell you the same thing. This heat pump has a COP of 3.5. It produces 3.5 units of heat for every unit of electricity you put in. And they're not lying. That number is real. But it is not the number that determines your energy bill, because that COP of 3.5 exists in a laboratory. Your house is not a laboratory. Let's start with what COP actually means. COP stands for coefficient of performance. If your heat pump has a COP of 3.5, it takes 1 kilowatt of electricity and turns it into 3.5 kilowatts of heat. Compare that to a gas boiler, which has a COP of roughly 0.9. For every unit of energy in, you get 0.9 units of heat out. On this metric, heat pumps win clearly. That part of the sales pitch is correct. The problem is how that COP is measured. Manufacturers test their systems under controlled laboratory conditions. Specifically, an outside temperature of 7 degrees Celsius and a flow temperature, that's the temperature of the water sent to your radiators, of 35 degrees. Under those conditions, a well-built heat pump achieves a COP of 3.5, sometimes higher. The question your installer is not answering is what happens when those conditions change, because in your house they will change every day of the heating season. There are 3 variables that determine the COP your system actually runs at, not the brochure figure, the real one. Variable 1, outside temperature. Heat pumps extract heat from outdoor air. The colder that air, the harder the system works and the lower the COP drops. At 7 degrees, the test condition, a rated COP of 3.5 is achievable. At -5 degrees, the same unit might run at a COP of 2.0. At -10, some systems fall below 1.5. Let's make that concrete. UK electricity costs roughly 24 pence per kilowatt hour. Gas costs around 6 pence. For a heat pump to match the running cost of a gas boiler on a cold January night, it needs a COP of at least 4.0. At COP 1.5, it costs more to run than gas. Not slightly more, significantly more. Variable 2, flow temperature. Flow temperature is the temperature of the water circulating through your heating system. Underfloor heating typically runs at 35 to 40 degrees. Standard radiators designed for a gas boiler often require 60 to 70 degrees to keep rooms warm. Here is why that matters. Every 10 degrees you raise the flow temperature, the COP drops by approximately half a point. A system-rated COP 3.5 at 35 degrees will run at roughly COP 2.5 at 55 degrees, just to keep existing radiators warm enough. If your installer plans to connect a heat pump to your current radiators without checking their output at low flow temperatures, the COP they're quoting you is a number your system will never reach. Variable 3, defrost cycles. When outside temperatures fall below roughly 5 degrees, ice forms on the outdoor unit. The system must reverse its cycle periodically to clear it. During those cycles, it produces no useful heat, but continues drawing electricity. This happens quietly in the background. It doesn't appear in the rated COP. Over a full heating season, it reduces effective output by 5 to 10%. Taken together, these 3 variables mean the figure that actually predicts your energy bill is not COP, it's SCOP, seasonal coefficient of performance. The average COP your system achieves across a full heating season. Cold days, mild days, defrost cycles and all. A well-designed system in a well-insulated UK home typically achieves an SCOP of between 2.8 and 3.2. On a carbon basis, that's still better than gas. On a pure running cost basis, at current UK electricity and gas prices, the saving is much thinner than a rated COP of 3.5 implies. A poorly designed system, wrong flow temperature, undersized radiators, inadequate insulation, can achieve an SCOP of 1.8 to 2.2. At those numbers, at current prices, you are spending more to heat your home than you would with gas. Not because heat pumps don't work, because this particular system was not designed for this particular house. That is the distance between the number on the brochure and the number on your bill. So what separates a well-designed system from a poorly designed one? 3 conditions need to be true at the same time. First, a heat loss calculation exists for your house, not a floor area estimate. An actual calculated figure in kilowatts based on wall construction, window sizes, insulation levels, and ceiling height. Without this number, the installer cannot size the heat pump correctly and cannot predict the flow temperature your system will need to run at. Second, your radiators have been checked for low flow temperature output. Either you have underfloor heating or each radiator has been calculated to deliver enough heat at 45 degrees or below. If the plan is to connect the heat pump directly to your existing radiators without that check, your flow temperature will be too high, and your SCOP will reflect it. Third, ask for the projected SCOP based on your heat loss figure, your local climate, and your system design. That number should be above 2.5 before the economics make sense. Here's the honest summary. The COP your installer quotes is real. It is not a fabrication, but it is a best-case laboratory figure, measured under conditions that occur for a limited number of hours each year in the UK. The number that predicts your actual energy costs is SCOP, the seasonal average. And that number depends entirely on how well your system has been designed. Before any installer quotes you a heat pump, ask 3 questions. What is the projected SCOP for my specific house? What flow temperature will this system run at during a cold week in January? And have you calculated the heat loss? Not estimated it, calculated it? If they cannot answer all 3, they are not designing a system for your house. They are selling a product. Next, I'll walk through how to read a heat pump specification sheet so you can check these numbers yourself before anyone arrives with a quote.